Your AC hums non-stop all summer. Your bill climbs every July. But air conditioning wasn't even invented until 1907, and it didn't dominate American homes until the 1950s through the 1970s. So before that, how did entire houses stay cool for decades? One method did the job at practically zero cost, and then it vanished from new construction entirely. In the early 20th century, American houses handled summer heat through passive design. Families relied on high ceilings, shaded sleeping porches, and operable windows to catch passing breezes. But as electricity reached more neighborhoods, a new mechanical strategy took hold to actively pull heat out of the home. This was the attic ventilator, a heavy, large-diameter fan mounted directly into a ceiling or attic floor opening. Unlike a standard window fan that only cools a single room, this system targeted the entire house. When turned on, the massive blades exhausted, rising hot air upward and out through the roof. This movement created a powerful pressure drop inside the living quarters, turning every open window downstairs into an intake vent. Cooler evening air rushed inside, sweeping through hallways and bedrooms to purge the daytime heat. From the 1930s through the 1960s, mail-order catalogs from Sears and Montgomery Ward advertised these heavy-duty systems alongside standard house plans. Mid-century manufacturers like Hunter and Chelsea built these systems for a specific comfort expectation, capturing the rapid drop in evening temperatures rather than trying to seal a house shut. This strategy became a mainstream necessity across the humid South, where purging stagnant daytime air was the only path to a comfortable night. But pulling off this whole home air exchange required moving massive volumes of air. How fast could a single fan actually replace the air inside an entire house? Under tests documented in National Institute of Standards and Technology, Technical Note 1138, a fan moving 5,000 cubic feet of air per minute replaces the air in a 2,500 square foot home in 3 to 5 minutes. This achieves 12 complete air changes every hour. Unlike room-by-room cooling, this pressure-driven system pushes warm indoor air into the attic and out through vents, drawing cooler outdoor air inside through open windows. This rapid exchange borrows natural coolness rather than manufacturing cold air. The process targets the house's primary heat reservoir, the attic. On a summer afternoon, solar radiation drives attic temperatures up to 140 degrees. Running the fan drops that temperature to 90 degrees. This 50-degree decrease halts the heat radiating down through the ceiling, cooling both the occupants and the building structure itself. Because the motor simply moves air instead of running a refrigeration compressor, it draws very little power. A typical whole-house fan consumes 80 to 150 watts. In contrast, central air conditioning draws 1 to 2 kilowatts, roughly 10 times as much. The idea of free cooling is shorthand. The fan does use electricity, but it avoids the massive cost of mechanical cooling. However, a fan only removes sensible heat. It does not dehumidify, making the energy advantage strongest when outdoor air is dry and cool. Popular histories often mark 1907 as the birth of modern air conditioning. However, archival patent records tell a different, more precise story. The breakthrough happened in July 1902 in Brooklyn, New York, inside the Sackett-Wilhelms lithographing and publishing plant. A 25-year-old engineer named Willis Carrier designed a mechanical system to stabilize paper rather than cool the workforce. High summer humidity caused the printing paper to stretch and warp, which made correct ink registration impossible. Carrier's system used chilled water spray coils to control moisture and temperature, solving a specific industrial crisis. Carrier filed a patent application for this invention on September 16, 1904. Granted on January 2, 1906, U.S. Patent 800,897 was formally titled Apparatus for Treating Air. The patent drawings illustrated a spray-type water coil and fan arrangement designed to wash, cool, and dehumidify the supply air stream. For the next 3 decades, this technology remained almost entirely industrial. The early systems were bulky, dangerous, and expensive. They relied on toxic refrigerants like ammonia or carbon dioxide, required heavy steel piping, and demanded specialized on-site engineering. These factors made residential installation impractical and economically impossible for the average homeowner. Instead, the American public first encountered mechanical cooling as a theatrical luxury. In May 1925, Carrier installed a centrifugal chiller at the Rivoli Theatre in Times Square. The installation altered the cinema business, drawing massive summer crowds to auditoriums carrying signs that read, "Cooled by refrigeration." By 1930, more than 300 theaters across the country adopted the technology, turning theaters into iconic refuges during the hottest months. The transition toward the home began to take shape at the 1939 New York World's Fair. Visitors toured the House of Tomorrow, a glass-walled residential concept that presented a sealed, mechanically conditioned living space. The actual path to household affordability began after World War II. Improved manufacturing, the expansion of the electrical grid, and the mass production of window units drove costs down. The introduction of smaller standardized split systems allowed developers to bundle central air into standard home financing, a shift exemplified in the massive suburban tract developments of the late 1950s and 1960s. According to historical records from the United States Census and the Energy Information Administration, less than 1% of American households owned any form of air conditioning in 1950. Over the next 30 years, ownership surged. By 1980, the adoption rate reached over 70% of homes nationwide. As central air conditioning became the expected standard, the whole-house fan quietly faded from new construction. Home builders shifted toward ducted, integrated climate systems managed by a single thermostat. It offered the ease of year-round comfort without requiring homeowners to open or close windows. Industry marketing heavily promoted the benefits of a sealed envelope promising filtered, dust-free indoor air. No federal, state, or local law ever banned whole-house fans. Their disappearance was a matter of market pressure and construction conventions. Stricter building codes and attic ventilation guidelines in the 1970s introduced design friction, while builders preferred to install standard all-air heating and cooling packages. The fan remained an effective way to move air, but the housing industry stopped treating it as the default solution. Today, whole-house fans remain a live product category, manufactured by companies like Quiet Cool, Tamarack, and Braun Newtone. Modern units move between 1,000 and 5,400 cubic feet of air per minute, drawing 70 to 160 watts. Installation requires mounting the unit in the ceiling joists, bridging the living area below and the attic above. The occupied house acts as the intake side, while the attic serves as the discharge path. For the system to function safely, the attic must have an unobstructed escape route. The National Institute of Standards and Technology recommends 1 square foot of net-free vent area for every 750 cubic feet of fan capacity. Without this, restricted airflow can cause pressure imbalances. Operating the system is straightforward. Open windows on the cooler side of the house before switching on the fan. Using a controlled intake route at night or early morning maximizes the cooling. Modern systems offer multi-speed motors, timers, remotes, and thermostatic controls. However, installing one requires a professional to evaluate wiring, structural joists, and backdraft risks. This active air movement builds on a long history of climate-responsive design. Between 1796 and 1803, Thomas Jefferson redesigned Monticello with a central octagonal cupola to serve as a thermal chimney. As documented in his June 8, 1803 correspondence, this passive system allowed warm air to rise and escape through the roof while drawing cooler air through lower windows. While Jefferson relied purely on gravity and temperature differences, modern motorized fans accelerate this identical principle. NIST studies show this method cuts cooling energy by 10 to 66% under ideal, mild conditions. But it is not a total replacement for air conditioning. When outdoor air is hotter than the interior, choked with humidity, or fouled by wildfire smoke, pulling outside air indoors ceases to be a cooling strategy. Everything I've documented across this channel, the food, the water, the soil, and the home itself, is available right now in the Lost American Home Manual. Get your copy at earlhadley.card.co or the link in the description. Make sure you're subscribed so you don't miss what's coming next. Tell me in the comments, do you run your AC constantly in summer, and would you try a whole house fan to cut that bill down? If you believe a trick that cooled homes for free for 50 years deserve better than being phased out of every new house, you already know what to do. Next time, I'm going to show you how our grandparents heated their water without touching a gas or electric bill at all.